Thank you, Pete. I'm wearing many caps. As a teacher, I'm a teacher, and also as an educator, researcher, you name them. So I want to present from the lens of the teacher first. And the reason for that is what you see of the mountain. There is a saying that what you see of the mountain depends where you are standing. But then I want to take you through the memory lane. We are here because of that, and we are indeed thankful for organizing this symposium and for us to swim in the same pool. It was highlighted that reform in the context of this symposium is to be understood as a shift towards goals and classroom practices such as those advocated in the theories of RME, problem-centered learning, and cognitively guided instruction. Taking you through the lessons we learned from Monday, I decided to group ideas. Where you see RME, you will know. Where you will be able to differentiate the arguments. We were able to get the argument from the RME that commencing mathematics teaching and learning at a more formal and abstract level without first engaging learners in formal knowledge does not develop conceptual understanding. Learner-centered instructional approaches should enable learners to move from their own intuitive solutions to more sophisticated formal strategies of working on problems. From Monday, I should think we were hearing things like this from different corners. I'm not going to bore you by repeating what presenters have already said. I'm just running through. Many presenters emphasized that learners are to be offered problem situations which they can imagine. You heard about this also. And there was a point where the emphasis was as long as the problems are experientially real in the student's mind. So there was a distinction between horizontal and vertical mathematization, and many examples were cited. And we remember what they meant by the two processes. And there are principles that go with RME: activity principle, reality principle, level principle, intertwinement principle, interactivity, and guidance principles. So you will be able to remind yourselves by reverting back to those principles. At the core is that mathematics should be meaningful. And all the speakers agreed that learners have to be active in constructing their own knowledge, and they should experience mathematics as a human activity and should reinvent conventional maths by mathematizing both subject matter from reality and mathematical matter under guidance of the teacher. You saw this morning. You remember that was Paul's presentation. It's centered around that model because it's still fresh. You remember it. From here, we should look at the program of work in a reformed classroom. That it may consist of a program of learning activities providing for developing of basic skills, factual knowledge, and representations. And this comes by periods and sessions in which we would like learners to engage. Therefore, there are some elements that we're running through. And those elements, according to Pete, and as we also would agree with them, are engage, articulate, reflect, refine, and extend. And the program, therefore, I've put deliberately a question mark to say, is that to be linear or non-linear? We'll come to this. But you can see that they are the sessions. And in each session, we expect that learners engage, learners articulate, learners reflect, learners refine, and also learners extend. So the expectation in a reform classroom could be summarized as that learning in which we expect much more than procedural and factual knowledge. So we expect that learners should learn to act mathematically, they should acquire conceptual knowledge, should acquire productive dispositions with respect to maths, and should engage in mathematical practices in increasingly sophisticated ways. This was a summary by Pitt to say the reform class could be captured in this manner. But then the gradual sophistication of procedures, inscription, and articulation should grow as we move from one session to the other with the learners. But does it necessarily work well? Does it necessarily work well? Or there are so many, as learners get all this because we are putting learners right at the center and they are to engage with the challenging tasks. As they do this, what assistance or how do we engage with them as they also engage in those challenging tasks? Hence, we tried to capture it in this secular form. But with all those ideas that we seem to be agreeing on, let's reflect on our South Africa. Let's be in South Africa now. We have the CAPS statements, and there are various views about teaching and learning mathematics still with the CAPS. And now there is a draft document that was heated by the group ministerial task team, and they refer to that as the Maths Teaching and Learning Framework for South Africa, Teaching Mathematics for Understanding. I learned there was a group that was focusing on this yesterday, but this still is to be formally presented to the bigger mathematics education community. And their model, as presented, we still have to engage on this and check if we share the same philosophy as they have. But we had so many presentations on creation of a dynamic classroom culture. So we still have to check if our voices are within what is being referred to here. So if we refer to how they describe the maths in the CAPS, is so excellent, and it agrees with how it's being viewed from the different countries. It's a language, a human activity, and it should develop mental processes, and in those with enhancement of logical and critical thinking, accuracy, and problem solving should be there. But the interpretation of this, as I captured in the framework, maths teachers should be planning and presenting lessons that engage. So the engage is a running action verb. In conceptual thinking about maths ideas, you have been raising this, developing their maths language in order to express themselves mathematically. All this still go back to what I indicated, that in each and every session, students should be doing. We are talking of teachers, yes, they are learners, but teachers would prefer us to give them support to improve their future classrooms. Teachers' role in all the presentations we had from Monday, it appears the teacher is at the epicenter of the learning process. And in the context of the reform mathematics, they should guide the sophistication as explained by Paul, specifications, institutionalization of mental methods towards conventional formats, the didactic as put. So in a way, we are trying to struggle with deconstructing the maths as a human activity and a body of knowledge, with education in view is a prerequisite for designing quality tasks for learning and articulating advanced curriculum goals and providing adequate initial teacher education and in-service. I just intentionally try within the slides put what makes the reform difficult. We shared a lot about what makes reform difficult. But in the South African context, a quick response could be, as long as teachers do not see their role changing with reforms, nothing will change in their classrooms. Without teachers experiencing the kind of teaching and learning envisaged, the good intentions will never be realized. That means teacher quality matters. There is this sort. Somebody can say, let us get rid of the teacher and then allow learning to take place. Will we manage? From the teacher's perspective, we'll be saying, we are trying our best. If you look at these cartoons, it says, I taught Stripe how to whistle. I don't hear him whistling. I said I taught him. I didn't say he learned it. So where are the learners? Teaching towards learning as a process task consciousness. So to promote learning to an extent to which learners are conscious of what is going on. That's what I summarized for this cartoon. But then one of the factors that would always affect maths performance of learners, as we heard from Monday and the other, is that there is a variety of teaching and learning styles in mathematics lessons. And each of those depend on on or influenced by the teacher's knowledge. That's the skills, attitudes of mathematics and the teacher's knowledge about mathematics. Some points to ponder. We must acknowledge that teachers are very special people. Indeed, they are special, but we seem to want them to be superhuman. There is no time to experiment with learners because they grow up too quickly and we have but one chance to educate them and equip them. The kinds of tasks, questions, classroom interactions, and targeted content that ground maths teaching and learning within and across the different educational levels, in most cases, as witnessed when groups were presenting, seem to lack coherence. They lack focus on important maths and lack appropriate articulation. That's the argument from other groups. I want to stay a little bit on this one. Teaching for conceptual understanding. All our discussions, all our presentations, whatever good framework you can come up with, seem to revolve around what I refer to as teaching and learning philosophy for the teaching of maths, for the teaching and learning of the mathematics. So at the center is a learner. A learner could be me, could be a teacher, could be a learners as we know learners, could be an educator, could be a textbook author, whichever way we are. If the person, and if we put that learner right at the center to develop self-identity, there is no way we can't work with learning material development. And if I'm a learner and put at the center, I should engage with that learning material development rather than somebody taking me through without me making sense of that. And in each and every maths classroom, learner-learner engagement is expected to be there. And also learner facilitator. Therefore, the learner should engage, or the learner should find himself, or the learner should be subjected to an environment where there is engagement of the form. But if we want to take it further, there should be a shared and continual reflection on the philosophy that we might agree upon. Hence, with this model, shared and continual reflection on philosophy should be considered. With the learner engagements, when the learner engages with the material, that enables the learner to make sense of maths as a domain of conceptual activity. That is rewarding in the sense of personal identity. If we put the learner's identity at the center, and useful engagement with aspects of reality. And in that way, it will enable the learner's formation of own opinion for later engagements. Learners want to be the authors of their own thinking.